Hello viewers, in our previous lesson we learnt about trigonometric ratios and a few identities. In today's lesson we will learn about trigonometric ratios of complementary angles and the use of these ratios in finding out unknown heights and distances. Here is a right angled triangle, right angled at B. So, angle B is 90 degree. If we take this angle C as theta, then what will be angle A? It will be 90 minus theta. Now, we know that cos theta is equal to the adjacent side upon hypotenuse, which in this case will be equal to the side BC upon AC. And what will be sin 90 degree minus theta? We know that sin 90 degree minus theta is equal to the side opposite to the angle 90 degree minus theta upon hypotenuse. So, again sin 90 degree minus theta will be equal to the side BC upon AC in the case of this triangle. So, we find comparing these two that sin 90 degree minus theta is equal to cos theta when theta is greater than 0 and less than 90 degree. We can also check that for theta is equal to 0 degree, cos 0 degree is equal to 1 and sin 90 minus 0 becomes sin 90, and we know that sin of 90 degree is again equal to 1. So, for theta is equal to 0, this is defined. Again for theta is equal to 90 degree, we know that cos 90 is equal to 0 and sin 90 degree minus 90 degree becomes sin of 0 degree, and we know that sin of 0 degree is equal to again 0. So, again for theta is equal to 90 degree also this equation is defined, and therefore, we have sin 90 degree minus theta is equal to theta for every theta greater than or equal to 0 and less than or equal to 90 degree. Again let us consider the same triangle. Here again the B is angle B is 90 degree, angle C is theta, and as we earlier said that angle A becomes 90 degree minus theta. So, what will be sin theta in this case? Sin theta will be the side opposite to the angle theta, that is AB in this case, upon hypotenuse, that is AC. So, sin theta becomes AB upon AC. And what will be cos 90 degree minus theta? As we know that cos 90 degree minus theta will be the side adjacent to the angle upon hypotenuse. So, again in this case also cos 90 degree minus theta becomes AB upon AC. Comparing these two, we can again write that cos 90 degree minus theta is equal to sin theta for every theta greater than 0 and less than 90 degree. You can also check that for theta is equal to 0 degree, sin of 0 as we already said is equal to 0, and cos 90 minus 0 becomes cos 90 whose value is again 0. So, for theta is equal to 0 degree, this equation is defined. Let us check for theta is equal to 90 degree. We have sin 90 is equal to 1 and cos 90 minus 90 becomes cos 0, whose value is again 1. So, again for theta is equal to 90 degree also we find that this equation is defined, and hence we have cos 90 degree minus theta is equal to sin theta for every theta greater than or equal to 0 and less than or equal to 90 degree. Again let us consider the same triangle with same angles. Here what will be tan 90 degree minus theta? We know that tan 90 degree minus theta is equal to the side opposite to the angle theta, which in this case becomes BC, because we are considering this angle 90 degree minus theta upon the adjacent side. So, if this is the angle in consideration, then adjacent side becomes the side AB. So, tan 90 degree minus theta is equal to BC upon AB. And what is cot theta? Cot theta again as we know is equal to the adjacent side to the angle under consideration. Here the angle under consideration is theta upon the side which is opposite to the angle theta. So, again we have cot theta is equal to BC upon AB. Comparing these two, we again have tan 90 degree minus theta is equal to cot theta for every theta greater than 0, but less than 90 degree. Let us check for theta is equal to 0. When theta is equal to 0 degree, we find that both cot 0 as well as tan 90 minus 0, that is tan 90, they are undefined. So, tan 90 and cot 0, they are undefined. So, this equation is not defined for theta is equal to 0 degree. What about theta is equal to 90 degree? When theta becomes equal to 90 degree, we have cot of 90 degree is equal to 0 and tan 90 minus 90 is tan 0, which is equal to 0. Therefore, for theta is equal to 90 degree, we find that this equation is defined, and hence we have tan 90 degree minus theta is equal to cot theta for every theta greater than 0, but less than or equal to 90 degree. Similarly, we have cot 90 degree minus theta. Now, I am very sure you will be able to tell what will be cot 90 degree minus theta. It will be the side opposite to the angle under consideration, which is AB in this case, upon the side opposite to the angle under consideration, that is BC in this case. So, cot 90 degree minus theta here is AB upon BC. Also, tan theta will be equal to the side opposite to the angle under consideration, which is again AB here, upon the side adjacent to the angle theta, that is BC. As you can see that these two are again equal. So, cot 90 degree minus theta is equal to tan theta when theta is greater than 0 and less than 90 degree. Again you can check that for theta is equal to 0 degree, tan 0 degree is equal to 0 and cot 90 minus 0 becomes cot 90, whose value is again 0. So, for theta is equal to 0 degree, this equation is defined. What happens when theta becomes equal to 90 degree? Let us see. When theta is equal to 90 degree, then tan 90 is not defined and cot 90 minus 90, that is cot 0, is not defined. So, for theta is equal to 90 degree, the equation is undefined, you can say. Hence, we have cot 90 degree minus theta is equal to tan theta whenever theta is greater than or equal to 0, but less than 90 degree. Similarly, we associate secant theta with cosecant theta. We have for secant 90 degree minus theta, we can write it as 1 upon cos 90 degree minus theta, because we know that sec theta is equal to 1 upon cos theta. We also know that cos 90 degree minus theta is sin theta. So, this expression can be replaced by 1 upon sin theta. And what is 1 upon sin theta? It is cosec theta. So, we get secant 90 degree minus theta is equal to cosec theta whenever theta is greater than 0 and less than 90 degree. Also, for theta is equal to 0 degree, we know that secant 90 minus 0 becomes secant 90, which is undefined, and cosec 0 is again undefined. So, for theta is equal to 0 degree, this equation, that is secant 90 minus theta is equal to cosec theta, is not defined. What happens when theta becomes equal to 90 degree? When theta becomes equal to 90 degree, we have sec 90 minus 90, that is sec 0 is equal to 1. Also, cosec 90 is 1. Thus, we find for theta is equal to 90 degree, this equation is defined, and hence we have secant 90 degree minus theta is equal to cosec theta whenever theta is greater than 0, but less than or equal to 90 degree. Similarly, we have cosec 90 degree minus theta is equal to sec theta whenever theta is greater than or equal to 0, but less than 90 degree. Using these results, let us solve a few problems. Here is a problem: sin 90 degree minus a into cos 90 degree minus a upon tan a is equal to 1 minus sin square a. We have to prove this, that left hand side is equal to right hand side. So, let us start with left hand side. On the left hand side, we have this expression. This is equal to sin 90 degree minus a, as we know, is equal to cos a. So, we replace sin 90 minus a by cos a into cos 90 degree minus a, as we have already proved, is equal to sin a. So, this can be replaced by sin a upon tan a can be written as sin a upon cos a. Now, this cos a goes to the numerator, and we have from this the expression. This is equal to cos a into sin a upon sin a multiplied by this cos A goes to the numerator as we said earlier. So, here we have cos A. Now, this sin A and this sin A gets cancelled from the numerator and the denominator, and we have ultimately this is equal to cos square A. And what is cos square A? We learnt in a previous lesson an identity that cos square A plus sin square A is equal to 1. So, cos square A becomes equal to 1 minus sin square A, which is what we wanted. We started from left hand side and the right hand side is 1 minus sin square A, and we have reached that point. So, this is equal to right hand side. So, that proves our result. Let us take another problem. We have to find out the value of 5 sin 17 degree upon cos 73 degree plus 2 cos 31 degree upon sin 59 degree minus 7 sin 80 degree upon cos 10 degree without using the tables, that is trigonometric tables. How can we find out the value of such an expression? Let us see. Now, this expression can be written as 5 times sin 17 can be rewritten as sin 90 degree minus 73 degree upon the denominator is kept as it is, that is cos 73 degree. Next expression plus 2 times cos 31 degree can be written as cos 90 degree minus 59 degree upon the denominator kept as it is, that is sin 59 degree minus the last term here, that is 7 times sin 80 degree can be written as sin 90 degree minus 10 degree upon the denominator, that is cos 10 degree. We know that cos 90 minus theta is equal to sin theta and sin 90 minus theta is equal to cos theta. We have just proved that. So, using these results, we get here 5 times sin 90 degree minus 73 degree becomes cos 73 degree. So, we write it as 5 times cos 73 degree upon the denominator kept as it is cos 73 degree plus 2 times cos 90 degree minus 59 degree is nothing but sin 59 degree. So, we replace this as sin 59 degree upon sin 59 degree denominator as it is minus sin 90 degree minus 10 degree is nothing but cos 10 degree. So, 7 times cos 10 degree upon the denominator cos 10 degree. Now, this is equal to cos 73 degree upon cos 73 degree is 1, again sin 59 degree upon sin 59 degree is 1, here also cos 10 degree upon cos 10 degree is 1. So, we have from this term we have 5 plus here we have 2 minus 7, and what is the result here? The result is 0. As we said earlier, these trigonometric ratios help us in finding out unknown heights and distances. Here is the problem. 2 pillars of equal height stand on either side of a roadway which is 150 meter wide. At a point in the roadway between the pillars, the angles of elevation of the top of the pillars are 60 degree and 30 degree. Find the height of the pillars and the position of the point. Here is a model of this problem. These are the two pillars. This is the roadway. The distance between these two poles is 150 meters. Suppose at this particular point, this pole is making an angle of 60 degree and this pole is making an angle of 30 degree. We have to find out the position of this point and the height of these poles. Here is the figure of this model. These are the two poles AD and BC, and at point E the pole BC is making an angle of 30 degree and the pole AD is making an angle of 60 degree. Let us suppose that this distance AE is x, and let us take the height of these poles as h meters. Then in triangle AED, tan of 60 degree will be equal to h upon x. This is equal to h upon x, which gives us h is equal to x times tan 60 degree. Now consider the triangle EBC. In this triangle, if the distance AE is equal to x, then the distance EB will be 150 meters minus x. So, in this triangle, in triangle EBC, we have tan of 30 degree is equal to the side BC, which we have already taken as h because BC is equal to AD, they are the heights of the poles. So, h upon this distance BE, that is 150 minus x meters, which gives us h is equal to, in this case, 150 meters minus x meters multiplied by tan 30 degree. Now, if this is considered as equation number 1 and this equation is considered as number 2, then this equation is also giving us the value of h and this equation is also giving us the value of h. So, these two values must be equal to each other. So, from equation 1 and 2, we have x times tan 60 degree is equal to 150 minus x into tan 30 degree. But tan 60 degree is equal to under root 3, the value of tan 60 is under root 3 and the value of tan 30 degree is 1 upon under root 3. So, replacing these values, we get on the left hand side x into under root 3, this is equal to 150 minus x into 1 upon under root 3, or this implies that 3x is equal to 150 minus x. X can be taken to the left hand side. So, this becomes 4x is equal to 150 meters, or x is equal to 150 upon 4, this is equal to 37.5 meters. So, we find that the distance AE, which was represented by x, is equal to 37.5 meters. So, what will be the distance BE? BE will be 150 minus 37.5. So, we get BE is equal to 150 minus 37.5 meters, that is equal to 112 0.5 meters. Also we have to find out the height of these poles. Now we can use either of these two equations, equation 1 or equation 2, for finding out the height h, because we already know the value of x now. So using equation 1, what do we get? Let us see. H is equal to, we had x into tan 60 degree. This implies h is equal to x, we just now found, it is equal to 37.5 meters into under root 3 the value of tan 60 degree. So this gives us the value of h is equal to, taking the value of under root 3 as 1.7 approximately. So 37.5 into 1.7, that is 63.75 meters. Thus height of the two poles is 63.75 meters, and the point from where the two poles are making angles of 60 degree and 30 degree, that point is at a distance of 37.5 meters from one pole and at a distance of 112.5 meters from another pole. Here is another problem. The pilot of a helicopter at an altitude of 1200 meters finds that two ships are sailing towards it in the same direction. The angles of depression of the ships as observed from the helicopter are 60 degree and 45 degree respectively. Find the distance between the two ships. Here is a model of this problem. This is the helicopter. At one particular moment it is at an height of 1200 meters from the ground, and from this point it observes that two ships are approaching towards it. This is the line of observation of this helicopter, and it finds that one ship is making an angle of depression of 60 degree with this ship, and this ship is making an angle of depression of 45 degree with the observer. So that means this angle of elevation becomes 60 degree and this angle of elevation becomes 45 degree. We have to find out the distance between these two ships. Here is the figure. The helicopter is at point A. It observes that one ship which is at point C is making an angle of depression of 60 degree with this helicopter, and another ship which is at point D is making an angle of depression of 45 degree with this observer at point A. We have to find out the distance between C and D, or the distance between the two ships at point C and D. I leave this problem for you to solve. You can solve this using cot theta, cot 60 degree and cot 45 degree. Thank you for being with us.